Hi everybody, welcome back to this new video. In this one, we will explain to you the architecture used to deploy our OpenStack cluster. In the previous video, we have seen the OpenStack in action where we deploy or create a new instance in our cluster and also create a new volume in this cluster. But in this video, we will deep dive in the architecture used to deploy this OpenStack cluster. And as you can see here in your screen, we have this architecture called AC Intelligence OpenStack or Lab architecture. It is a virtual environment used for this lab environment. So we have a physical server called host lab1, which is the host name of the physical server. And this server has been visualized with KVM. And on top of this KVM part, we have deploy some virtual bridge. I can see here, and some of those bridges have been enhanced with Open vSwitch. Because with Open vSwitch, we will be able to have the VLANs capability in order to have the network segmentation for this deployment. As you can see here, we have many VLANs that are being used for this deployment. The management network that we have here have to have access to internet, and with this provision net permit us to provisioning or deploy the different operating system in each node that we have in our infrastructure. Okay, and this both networks it is just a isolated network of this permit have to distribute. Okay, or to have different numbers of VLANs, just to simulate a real-world scenarios. Because in the real world, you can have many switches for your OpenStack cluster. So this architecture intend to have to be stick to the real-world environment. And after deploying those virtual instances, those virtual bridge networks, we have now to define the different nodes that we have to provisioning during our instance or our deployment. Okay, so we have those infrastructure nodes, which are the MAAS, the Meta as a Service node. We have also the Juju controller node. Both nodes will be our infrastructure nodes that will permit us to deploy and configure our OpenStack cluster. And on top of those infrastructure nodes, we have the OpenStack nodes. That we have here. We have the controllers node, we have compute nodes, we have also the Ceph storage nodes. Okay, just to be specific, it will be the Ceph OSD node, because those nodes will just embed or have inside of the drives, the OSD drive only. Okay, and inside of the control node, for those who are very used to the OpenStack world, we have the control node, and those ones will have different services like Keystone, the database, the Neutron services, the Glen service. Okay, and those ones will be in HA, okay, in availability configurations. And inside this controller node, we have also deployed the Ceph controllers component, which I mean the Ceph manager, the Ceph monitor, and the Ceph MDS also. So those controller component of Ceph storage will be deployed in the controllers node, just to not waste nodes, because we have in lab environmental no need to have so many nodes in this lab environment. So the Ceph monitor, the Ceph monitor manager, and MDS of those components will be have been deployed on those same controllers node. Okay, and yeah, as you can see here, it is a pretty interesting architecture that we have been, and how we think that we will be able to share it with you Okay, but in the link, because we will share with you a link where we will be able to download this architecture. Okay, and let's go back in the physical, let me show you the dashboard. If you remember, we have this dashboard, your OpenStack cluster dashboard here. Just to remember you, we have hypervisors where you can see the compute nodes. The both compute nodes are represented in our architecture. Okay, we have above compute node. We have also the controllers node in our environment. But let me go back here. We have here a physical node. Let me show you how it looks like. This is our physical node called Lab 1. And in this physical node, we have visualized this physical node with a KVM. So this is where we can see those VMs. So in reality, those ones are all VMs that we have deployed on our physical server called Lab 1. Okay, and in this Lab 1, we have created a virtual bridge. Those virtual bridges are, let me show you. We have many virtual bridges in our physical server because we use it for another project. But anyway, we can see the different virtual bridges here, the management bridge. We have also the isolated bridge. We have also the bare metal bridge, as you can see here. Okay, so those are the different bridges used in our deployments. And if I say very short, here is the different nodes that we have in our cluster. If I hit this command, for instance, okay, you can see that our storage nodes are connected on those bridges. Okay, we have the provision net bridge, the bare metal bridge, and the isolated bridge. And here we can see we have a dual connection because the interfaces will be bounded. Okay, I will talk to you in another part of this video, because in real world deployment, interfaces are bounded. So I will show you that the file, the charms used to deploy the OpenStack layer also take this pointer in account. Okay, so we can hear the same things for the controller node also. We have same thing. So controller node also is connected on the both on the different bridges. Okay, yeah. Next step. So we have another let's go to the infrastructure nodes. Here we have the infra MAAS. We have also the Juju controller. Yes, this one, and this let me just call back this command. I don't want to type it, to not waste time. If you remark, this infra MAAS is connected to the bare metal networks and provisioning network and the management network. It's because we use it to have our gateway to have access to internet simply. Okay, so we don't have to complicate ourselves. So this infra MAAS is the gateway to have access to internet for our whole infrastructure. So this infrastructure gets access to internet, okay, through this infra MAAS. Okay, so it is a form, some sort of security. So we can it don't allow all nodes to be exposed to the internet, but it will be only through this one that will have access to internet. And which is also next step after done that. So I've shown to you. So let's go to another point about during the deployment process, the MAAS, the meta service, have to shut down and start up nodes during the deployment process. So to do that, or to achieve that, or to simulate that, or you use the virtual BMC, the power management. This component permits to shut down and start up our node if needed. So let me show you also how it looks like. We have a virtual BMC. Okay, we have a different node here. We have our three nodes, our storage nodes. We have the controllers node here, and it is through this virtual BMC that when we are the meta service have to shut down or start up node, it will be through this virtual BMC that those actions will be performed. Great. This one is okay. I hope that if it will be okay for you. And other things, let's go to dive another point on another point. I think that all these are okay for you. And of course, we have an address planner that has been reserved for this deployment. Okay, so the use of the MAAS to start up and shut down different to provisioning operating system of the node. Let me go on the dashboard of this component. Okay, I will go on the dashboard of the MAAS, the meta service. Let me show you it. Here is how it looks like. In my previous video, I've already made a video about this meta service provided by Canonical team. This permits to manage 10 server, 50 server, 100 server. Okay, if you intend to manage those servers, you can use the meta services to deploy any kind of images on those service physical server which have no operating system, and you do it through the PXE, okay, technology. Yeah, and you can see here all nodes are right now up and running, and here is the IP that they are getting through the provisioning network. Okay, it's through this provisioning network that all nodes get the IP. So all nodes have they have the IP on the provisioning network, as you can see here. And the image deployer on each node is Ubuntu 22, as you can see here. And what things else? I would like to show many things. And regarding the networks part, let me show you. This meta service should know or should have the information about your network topology. So we have to replicate your network topology in this meta service, because during deployment, the Juju will request virtual IPs and IP addresses, and those requests will be sent to this MAAS, and this MAAS should detect should be able to allocate new IPs to your Juju deployments. So it's very important for you to replicate or to say, here is my network topology that I have at the moment. And you have to declare all subnets in your infrastructure. So as I've done here, I've declared all subnets in my infrastructure. I also deploy or declare the different spaces, because it will be through the spaces that each component will request IPs and virtual IPs during the phase of deployment. Okay. So I hope that, and here you can see here, we have a provision net and we have a network range. It will be through the DHCP that all those IPs will be distributed. Very important. So when you intend to deploy your OpenStack cluster with Juju and MAAS, you should replicate your network topology in your MAAS and platform. Great. Okay, on that, let me show you also the image. I have used this is I've used the image 2022, okay, 22 for the deployment. as you can see here. Okay, and which things else? Yes, I think that I have shown to you many things. I hope that you have gathered much more information about this architecture and the different component user for this deployment. And here is the MAAS controller where we have this dashboard. Okay. In production environment, of course, we can't have only one node. You should have a clustered node. You can have 3 nodes for your MAAS controller, just to have an high availability. If one node is fell down, you can still get access to your MAAS infrastructure through others node. So in production environment, you can't have only one node. No, you can't. You should have 3 node in clustered node for your MAAS infrastructure. Same thing so for your controller of Juju. Okay. Okay, once done that and everything is okay, great and perfect, let me show you. It is a little bit slow. Okay, so let me show you how can. Here is some characteristics. It is just a basic deployment that I've done. You can see also the characteristic of this node. We have just 8 GB of RAM used for this deployment of the MAAS controller. For the CPUs, there are also 4 CPU, this virtual CPUs used for this deployment also of the MAAS controller. Yeah. Okay. And what is else? Let me show you something. Here is for the deployment. Okay, let me show you the charms used for this deployment. And before going to a deployment, we have many layers in this infrastructure deployed. We have we have the provisioning. So the operating system that should be deployed on the different servers. Okay, because when you have your rack, okay, so your rack, and we have a different racking servers, there is no operating system. So it will be through MAAS that we have to provisioning operating system on those physical server. Okay, here in my case, I have created. Here is how I have created each node. Okay, each node has been created with no operating system. No operating system has been assigned to each node. As you can see here, here is how I have proceeded to deploy each node, to create each node. I've just defined it because I'm in a virtual environment, so I have to proceed in some way, of course. Yeah, so I've done it through this manner. Okay, so when I've done this one, there is no operating system on each node, as you can see here. And it will be through the MAAS that each node will be a receiver its operating system. And once done that, the next step will be to configure network interfaces. I repeat again, after provisioning the different network, the different operating system, we have to configure the network interfaces, because you should create bonding on this each node. Okay, we have to assign IP address on each interfaces. So I have done it all through the Ansible, the Ansible template, the Jinja 2 template, or with Ansible. Those things permit me to configure the network interfaces of the different nodes in my cluster. After done that, only after the provisioning operating system and configure network interfaces, only after those both things, and I will be able now to start the charms to deploy the operating system. Okay, so first provisioning OS. Second, we have to configure network interfaces. And third, deploy your charms, which permit to configure and deploy the application layer in your on your different nodes. Okay, and let me show you how it looks like. No, it's coming back here. Yeah, here is, for instance, of it was very tough networks to achieve this one. As you can see, we have many charms defined, but here is the final charm, so which finally succeed, and with which I have finally finalized the deployment. Here you can see that I have defined I have defined the different components that I would like to have in my OpenStack deployment. Let me show you here. Okay, here I have defined the different machine. Okay, very different. I have 3 controllers, 2 computer, 3 storage nodes. Okay, and each one have its ID. It's very important, those ID, because it will be based on those IDs that I will be able to distribute the different components. And this deployment, it's the containerized deployment. It's not a bare metal deployment. It's a containerized deployment, which means that the different components like Keystone, MySQL, and the glance and so on will be containerized. Okay, it will not be a bare metal installation. So here we have different. First of all, we have the MySQL, for instance, application deployed on those containers. Okay, and we have, you can see, same thing for the Keystone component, and of course, Keystone also have to be able to connect it to the MySQL, and all relationship will be defined. So it is in these charms of the Juju that where I have defined my network topology, or my application, my OpenStack application topology. Okay. Yeah, it was a very interesting project, and I took part. And if you would like to deploy it also in production, you can consider it. But it is the learning curves can be a little bit very hard for those who are not prepared for that. But when you master this deployment, I think that you get something very hard, very deep. And regarding the maintenance and troubleshooting, it's very simple and easy. When deployment has been done very perfectly, it's very interesting for scale your cluster, to maintain your cluster, and troubleshoot also your cluster. Of course, you should know the basic of Linux commands, because you have a layer of physical nodes, layer of containerized node, and then the layer of application node. So all node layers should be very well troubleshoot and well understood to be able to easily troubleshooting any issues that may be able to occur. Okay, great. And what things else I can show you? Okay, so thank you very much, and I hope that you gather very interesting information during this video. I don't want to make it very longer. We have to stop it here. And if you have any comments, questions, and issues, you can drop down comments. And don't forget to like and share or subscribe to our channel. This permits us to have some motivation to create much more content like that. So guys, thank you very much again, and have a very good day. And don't forget to replicate this kind of infrastructure or lab environment in your servers. Thank you very much. Bye from now.